Okay, so an isotherm is anything along this line right here that has a constant temperature. So this is called an isotherm. Isotherm. And in one of the graphs that was given on those questions for you, there's some little dotted lines that are extended. Those are the isotherms. So along this line, though, temperature is constant. T is constant. So tell me, let's look at the first law of thermodynamics, and that is delta U. The change in internal energy is equal to the thermal energy added to or removed from the gas plus the work done on the gas. So what about delta U? What does delta U depend on? Delta U depends on temperature. Very good. And for an isotherm, is our temperature changing? No. So because delta T is 0, then delta U is 0. How about that? So plugging that back into our first law, 0 is equal to Q plus W, which means that Q will equal negative W. So since the change in internal energy is 0, because the temperature doesn't change, then the thermal energy added to or removed from the gas will be equal to the negative work done on the gas. Okay? Now, our fourth type is adiabatic. An adiabat is what they're called, the curve that makes up the adiabatic process. You have pressure and volume, and hopefully I won't misspell it here, adiabatic. Is that right? Okay. It's a process in which the thermal energy does not change. So adiabatic thermal energy does not change. That means delta Q is 0, but temperature, pressure, and volume change. And so it looks like an isotherm, but it's not. It's still curvy, just like an isotherm. So the only way you can tell an isotherm from an adiabat is to test with the combined gas law equation. Do you remember the combined gas law equation? P naught V naught over T naught equals PV over T? Okay, so let's look at this in the first law of thermodynamics. Delta U is equal to Q plus W. So the change in internal energy of the gas is equal to the thermal energy added to or removed from the gas plus the work done on the gas. So in this case, Q is going to be 0. So that means that delta U will be equal to W. So that means the change in internal energy is equal to the work done on the gas. The change in internal energy is equal to the work done on the gas for an adiabatic process. Now let's look at the Feve Nert. All right, so if NR is equal to PV over T, right? That's Feve Nert. PV equals nRT rearranged. Well, if the moles can't escape from the canister, then NR is the same no matter what PVT combination we're at. So that means that P naught V naught over T naught has to equal PV over T if N is constant. So we don't open the canister and let any of the moles out. How's that visual?